So to finish our linear functions review, I broke it into must, should, and coulds. We've already talked about using y equals mx plus b, but sometimes you can't see the y-intercept well, or it's not a pretty y-intercept. And sometimes you're not given information that isn't as useful as some other forms of equations of lines. So I want to go over a couple of other things with you. If the y-intercept isn't pretty, or you have some other problem, we do have what's called point slope form of a line instead of slope intercept form. So that's what we're going to go over for the should and could part of the videos. So point slope form. You've seen this before, but you probably haven't used it a lot. Point slope form of a line is y minus y1 equals the slope times x minus x1. So instead of using y-intercept and slope, you use some point x1, y1 and the slope. It looks a little ugly, but it's just another plugging in thing. So let's do a couple of examples. Okay. Let's say you're given the point negative 2, 3, and a line that goes through negative 2, 3 with a slope of 1/2. So I'm going to call negative 2x1 and 3y1. That's my point. My slope is 1/2. So we say y minus y1 equals m slope times x minus x1. So you just plug in. Y minus, my y value of the point I know is 3, equals the slope is 1/2 times x minus the x value of the point I know is negative 2. And then you clean it up. So y minus 3 equals 1/2 times x plus 2. When you subtract a negative, you get a positive. But what if you're asked to write the equation of a line through 2 points, say 5, 2 and negative 3, 1? Well, first you need to find the slope of that line. So using that slope formula we reviewed in the earlier video, change in y over change in x. So 2 minus 1 over 5 minus negative 3, or 1/8 is your slope. And then you get to choose either of the 2 points to use. It doesn't matter. You'll get 2 different looking equations that are equivalent, so we can do all that testing in class. I like to use the point that has everything positive, because negative numbers freak me out. So I would use 5, 2, and plug in and get y minus 2 equals 1/8 times x minus 5. Some people prefer to use the other point, negative 3, 1, and they would get y minus 1 equals 1/8 times x plus 3. If you distributed through and got everything in y equals mx plus b form, or graphed them, either way you would see that they're the same exact point, or same exact line. So the last thing I want to review with you for the should and could do part of this lesson are parallel and perpendicular lines. Real quickly, I know you did this in algebra. Parallel lines have equal slopes. So if you're asked to write the equation of a line that's parallel to some other line, you take the slope of the line you're given and use it. Keep the same slope, and then fill in the rest. If you're given a y-intercept, plug that in. If you're given a point, use point slope form. So for example, if I want the equation of the line parallel to y equals negative 1/2 x plus 3 that goes through the point 3, negative 2. Well, I have a slope, negative 1/2, and I have a point, 3, negative 2, so I'm going to use point slope form and say y plus 2 equals negative 1/2 times x minus 3, and be done with it. Likewise, perpendicular lines have negative reciprocal slopes. You flip the fraction and negate it. So a negative becomes a positive becomes a negative. So let's do one example. We want to write the equation of the line that is perpendicular to that other line that we talked about before, y equals negative 1/2 x plus 3, and goes through the point 0, 5. Well, 0, 5 I recognize as a y-intercept. So I have a slope of negative 1/2, a negative reciprocal slope of negative 1/2 is 2, my new slope is 2, and 5 is my y-intercept, so I can use y equals mx plus b in this case, and I get y equals 2x plus 5. And that is it.